So this is the June Databricks user group session. Today we're going to be talking about Spark MLFlow. And so kind of a cool thing with MLFlow that just came out of the recent Spark and AI conference is that MLFlow is now a completely open source project as part of the Linux Foundation. So this is, part of the Databricks user group, obviously, but it kind of goes more into some of the things we've been talking around the Databricks community, where a lot of the tools that we are using are now open source and collaborative and don't have a lock-in like you typically see with a data platform. So that's some exciting news off the top. I'm Spencer Cook. I've been running the last few of these. I'm a data scientist at Valorum Reply. I also want to call out that I've been doing in lockstep with these user group sessions, live coding sessions every Saturday, where we sort of dive deeper into the topics presented in these sessions than I'd have time within these 90 minutes. So I would encourage you to check those out. You can find links to it on the microsite that we've set up for the Valorum Databricks user group, and we can also get a link in chat. I also want to thank our moderators for in attendance and are going to be checking out the comments in the chat and keeping me abreast of your questions and everything else like that. But yeah, that's sort of the intro. Let's go ahead and go around. I think we've got some new people in the audience today. So we've got a small group. So if you want to unmute and introduce yourself and talk about what your exposure to Databricks is and sort of what you're hoping to get out of today's session, just so I can try and answer your questions, that would be great. We'll just start from the top. So I see Andres is in here.
Hey everybody, I am Andres Caldera. I'm with client partner with Valorum Reply, and I'm just here to learn something new. So looking forward to it.
Awesome, thanks Andres. All right, I know this guy, Andrew Fletcher.
Hi, yes, Andrew Fletcher. I'm just curious to see what's the new features and tips and tricks that came out of the Spark AI conference sessions that I was not able to attend.
Great. All right, Eddie.
Hi everybody, Eddie Edgeworth with Valorum Reply. I'm Spark certified and Databricks champion, and I'm just excited to be part of this user group.
Cool. And then I lost focus on that window. Jason.
Hi everybody, Jason Newsom. I'm with Valorum Reply, and I'm just learning Databricks, kind of getting started. I got a project that I'm working with right now that I think would be a great candidate for it. So I'm looking for exposure and here to learn.
Cool. Okay, and then Lindsay's one of our moderators. You know her, Luke Hoffman. I think I recognize Luke.
Yeah, hey, sorry, my mic was muted again.
No.
Yeah, I'm Luke. I'm with Untitled Chapter, and
right.
I don't really have much exposure for Databricks, but just here to absorb whatever you have.
Sweet, you're in the right place. Michelle.
Hi, I'm Michelle Mason from Valorum Reply. Same as everyone else, just enjoying this user group and looking forward to seeing what you got today.
Okay, cool. Scott.
Hey, data scientist. Databricks is evolving so quickly, it's really hard to keep up at times. So this is really a good way for me to keep up with what's going on. Databricks Summit had so much to offer. So this is a great place to come get that summary.
You're in the right place. Sean.
Hi there, brand new mic here. Not sure if it's working.
No, you sound great.
Data-driven insights group. I'm primarily involved in data engineering. I'm anxious to see what happens on the other end of the data value chain as you start making predictive models and getting moved out.
Cool. Trevor.
Everyone, I'm Trevor, data scientist with Valorum, and I am here because I'm always interested in Spencer's insights.
Appreciate it. And then Ty.
Hey there, I'm Ty. I typically do software dev with Valorem Reply, but Spencer's raved enough about Databricks. I just want to see what the fuss is all about.
Well, we will keep it relevant enough for software engineers too, I swear. I think there's a lot to learn, especially with Spark expanding every day. So yeah, thanks for the intros. Let's go ahead and get started. You should see the deck right about now. If anyone is not seeing that, say so in chat. And also, I'm going to try and pay attention throughout to the raised hands. So if anyone has a question and I don't recognize it, you can always just unmute and interrupt me. We've got a small crew, so no big deal. Okay, so I want to talk about MLFlow today, like I was saying. But first, I want to harp on the point we make at the beginning of every user group. Motivation from Valorem Reply as far as Databricks goes and our mutual partnership with Databricks and Microsoft is really just trying to accelerate insights and use that to improve performance for businesses. Now, the way data science fits into that is often self-explanatory, right? But one of the things that we'll see throughout this session and that we've really been sort of honing in on in our relationship with Databricks is how you can help companies actually go from talking about data science and ML to actually using it to drive revenue and change the direction of their business. So why MLFlow? So some of you commented on this, and I think it's going to be a perfect fit for the way I've structured these slides. We're sort of going to go through the history of MLFlow. So MLFlow was announced a little over 2 years ago. I believe it was June 5th, 2018. And it just got announced, version 1.9 just got announced at the Spark AI Summit that I was referencing about a week ago. And so if you think about other technologies that are 2 years old or even 5 years old, I think the rapid amount of growth with MLFlow, especially when you consider it in tandem with some of the other things that are coming out of Databricks and Spark, it's really kind of crazy to think about how far it's grown. But if we go back to our first Databricks user group session, I think it was in March or April, we kind of talked about the too many tools problem, right? And so if you're familiar with the ML or data science space, you'd probably recognize that this is already kind of outdated, right? And there's still an overwhelming number of technologies being released that seems like weekly that you have to keep up with, right? And so all these different organizations that release new machine learning and data science frameworks, and then on top of that, data scientists need to understand how to interface that with continuous integration and delivery systems, ML ops, data engineering. Containerization is becoming an increasingly large concern. Data scientists are increasingly overwhelmed with the number of supporting libraries and environments and their dependencies that they need to have available and installed and reckon with, right? Now, that complexity isn't going down. It's only getting worse, right? And so what is a data scientist to do? What's a data team to do? Well, it's not the frameworks that are the problem. They all exist for a reason. They all can solve really important ML problems, right? If we went through each of the bullets in this slide, we could really articulate, their specific features within the market that differentiate them. But what if instead of focusing on specifically the data and data munging and model training and the time building and debugging environments, you were able to focus on, the actual task at hand of ML, right? So this is a chart actually from the Introduction to MLFlow blog post on the Databricks engineering blog by Matej Zaharia, who's the chief technologist over at Databricks. So this is what the ML lifecycle looked like 2 years ago during this announcement, and it looks pretty similar, today. A lot of these technologies overlap with what we saw in the previous slide, right? And so if you think about it, this ongoing cycle you can't really avoid. You need to do, for instance, tuning and scaling for your data prep, right? And you need to pick tools for that. Similarly for your training. When you deploy, you're typically picking an entirely different set of tools. So like, let's focus on a couple tools through this life cycle, just as an example. So like I love Pandas. I used to use it almost exclusively before PySpark won my heart over. So Pandas is really, really good for data engineering, data prep, data cleaning type work. It got one of the most robust data frame APIs other than R and maybe now arguably PySpark. Although with the introduction of koalas and the increasingly pandas-like features they're adding, that could be debated too, I suppose. Well, if we're doing pandas to support deep learning, for instance, then we might pick a package like PyTorch or TensorFlow, right, for our training. Well, those are horrible for data prep and data modeling, right? So already we're kind of handing off, like we would probably vectorize our pandas data frame before passing it into PyTorch. Well, now we really can't go back, right? We're sort of over the wall and now we're in PyTorch world. Well, PyTorch doesn't really have a great programming API to interface natively with Azure ML or Docker, for instance, right? So if you want to host and deploy your model and scale it out on something like, Docker on Azure, or using Azure ML if you want sort of a point and click interface, again, you're now past another wall into an entirely different ecosystem, and it's really hard to go back and forth between the two. Similarly, once you deploy, you're going to get more and more data from, let's say, your website or whatever tool you're deploying a model against, and also results from your model, right? Well, that has to go somewhere. We're going to use either a Delta Lake, or we're going to use Microsoft Azure storage account, something like that, right? Well, now all of a sudden we have yet another environment and set of tools and set of APIs to deal with, right? And so if you think about the four main pain points this introduces, really it's the framework problems that we looked at in slide 4, just overwhelming number of frameworks, libraries, packages, etc., and lack of mutual compatibility. There's also not really a great way to do an end-to-end trace. Once something is deployed, what set of parameters, what tuning did we pick? What data from what day, from what table, from what ecosystem was it picking, right? Let me mute this real quick. And so that auditing, that lack of end-to-end composition wouldn't be acceptable in nearly any other realm of data work, right? But in data science, it's sort of still the Wild West, right? So then you also have to focus on production. Even with more advanced teams and mature teams than 2 years ago, getting models into production is still actually kind of a controversial problem. If you were to Google how to deploy a model from even one of the more popular machine learning frameworks, you're going to get endless different opinions about the best way to do it and what best practices are. And even once you do it, it's kind of delicate and it's not routine enough. It's not something that you're going to deploy as frequently as, for instance, you would an app service or even a microservice where you're getting continuous delivery, right? And once it's out, there's not necessarily a guarantee of quality. Integration testing and acceptance testing is still kind of a new thing within this ecosystem, right? And then finally, you oftentimes need massive sets of data to be able to train effective models with these existing tools. And oftentimes companies are kind of realizing too late in the game that they want to be data science companies, or they want to join this, new ML revolution. And it's kind of a chicken or the egg phenomenon where you need to be mature enough with your data already to do data science, yet you kind of need to see the data science working to be able to convince maybe other parts of your organization to invest heavily enough in your data architecture to be able to do data science, right? And so if you can sort of bootstrap that, if you can cut out that transition cost and get to the point where you're able to do this where a company might be at already, then that could really be huge for their overall growth, right? So this is another slide that we looked at in one of our first sessions, and I want to focus on part 2 and 3 here. So really, and we're going to dive deeper into these components, but really MLFlow is connecting 2 really crucial pieces of this unification. Obviously, Databricks Delta helps us with our data prep. It helps build out the data lakehouse model that we're trying to shift more and more things to. But really, for that entire data lifecycle, phase 2 of model building and phase 3 of model deployment and serving are entirely handled by MLFlow. And so the tracking API provides you the ability to track all your experiments in one place, regardless of their deployment location. And we'll talk about the philosophy of MLFlow in a later slide. But really, one of the things you'll continue to see, and you've probably seen this across Spark tools in previous sessions, is it tries to be platform agnostic. You could be deploying from on-prem, from Azure ML, even from something like SageMaker, and MLFlow is going to help you track the latest version, make sure it's integrated with Delta, having full data traceability for all your models. And then the ML serving packages help enable the data scientists to take MLFlow models and deploy them anywhere they want, which facilitates increased collaboration. It makes it so that you can have really enabled data scientists that aren't going through chains of IT and ML engineers to see their work get served up. In the same way that developers are able to push different feature branches and have them promoted via pull requests, you can see the same thing, but for your ML assets. And so we'll look at MLFlow in action and cover several of these features in a demo at the end, but keep a lot of these things in mind. Okay, so we've talked about why MLFlow is necessary. What is it? So this is another excerpt from Matei's introduction. It's really hard to do a better explanation than the guy who created it himself did, right? So I'll have links to these blog posts throughout the notes in the deck that we're going to share out at the end. But, MLFlow is inspired by ML platforms that already exist, but it's designed to be open, which is kind of controversial if you look at some of the ML platforms that already exist. So the first component of that is that it's an open interface. So MLFlow from its core is designed to work with existing ML libraries. It's not set to replace them or subserve them. It's just sitting on top of ML libraries, algorithms, deployment tools, whatever it might be that you're already using in your work, and it's built to enhance that. Similarly, it's not reinventing the tool or reinventing the wheel with the tools you use to interface and interact with MLFlow. It uses REST APIs, it uses very simple date formats, and it can be used within a variety of tools instead of, let's say, if you're using this ML package, you can only use this subset of MLFlow like we've seen with other tool sets. And so if you have an existing rich ML pipeline or set of tools, MLFlow can come in and sit on top of that and enhance it, even if it's already great. Similarly, if you don't have much going on, you can target MLflow from the start and get even richer integration and functionality by having it be a native part of your code base. And I want to call back again, that's one of the most exciting things about that donation of MLflow to the Linux Foundation. You can make MLflow a central part of your libraries, just like you would something like HTTP or SSH or Telnet or any other open source protocol, without having to worry about lock-in and it suddenly being a part of some company's code base and you're paying licensing fees for it or whatever. So you can confidently build around it. You're also able to share code using other ML libraries that other people in your organization can run, and they're going to be able to natively use MLflow. They don't have to worry about paying for some license or installing an esoteric package. It all just works. Now, point 2 is kind of interesting, again, to look at in reflection of the Linux Foundation announcement. So MLflow started as an open source project. You know, Databricks wasn't as big as they are now, but they were still big enough to where if they had been interested in it, they could have absolutely used MLflow like the Databricks runtime or Databricks workspaces, where it's something that's a value add for Databricks customers. But instead, it started open source, and that means that it's gotten enhancements and extensions from users participating in the community. It also makes it easy to share your workflow steps and your models across different organizations, or if you want to open source your own packages, which has really made it the healthy tool and package that it is. That's part of the reason we've seen so much growth over the last 2 years, because it's not just sitting locked down on a server on Databricks campus. So MLflow really breaks down into 3 key components. So tracking, that's where your records, your query experiments, all your data, code and data configuration assets, and the results of your experiments sit. Projects is a packaging format, things like Pickle or other serialized type formats for ML experiments. And that's what allows you to do reproducible runs across platforms. So similar to a Docker container, you know, YAML files, things like that. Really not reinventing the wheel, but having a standardized interface like this really does help, because it's, again, platform agnostic. So you get this reproducible format no matter what tooling you're using. And then finally, the models component. So that's the format for sending models up to deployment, registering them within, for instance, Databricks, things like that. Now, this is kind of what it started with. We're going to talk about in the last few slides some of the new things that were announced at last year's Spark conference and then this year's Spark conference that further enhance this functionality and enrich it. That seems to be the standard, not the exception for MLflow and the Spark platform more broadly. Is we're going to get new rich features year over year. So it's a lot to keep up with. So let's look at some examples of MLflow tracking. So like I said, it's really just an API and interface for logging your parameters, doing code versioning, tracking metrics, and then outputting files or managing where to output files when you're running your ML code that you can then later visualize. So this is just a couple lines of code, but it does enough to let you track parameters, metrics, and artifacts for a particular experiment. So if you do log param, you're going to create a key value pair between, in this case, the number of dimensions in a particular experiment and then the amount of regularization. And that's now being tracked internally by MLflow. And that's a parameter. So that's what you would say feed into a model, or, you know, tune if you're doing some sort of cross-validation approach, right, for your model training. Now, a metric would be the result of your model, right? So sort of inputs versus outputs. So you can also track those. So if we wanted to, for instance, say at this stage of the training, we're logging that our accuracy is blah, and now it's, you know, blah, blah, you can do that. And what that helps you do is, in the same way that logs help us know what's happening inside software as it runs, this helps us understand what's happening inside of models as they're being trained or even as they're being served up. And so we can look in real time and say, oh, when we use this set of parameters, we get this result for our metrics. Maybe we want to change that. Maybe we want to, you know, start from scratch, whatever. And we'll look at some examples of how that works in Databricks today in the demo. And then finally, with artifacts, you can track where the files that contain your model or relate to your model live. So in this case, we're logging a pickle file for your model and a PNG image of an ROC curve. And so you can associate that with an experiment and get both of those back later, and also see this ROC in pickle came from this set of parameters. It had these metrics, and using Delta, you can even say it used this data, right? And so you can already see how we're getting more of an end-to-end governable way of doing ML versus the existing tooling. So the way this looks within your environment, if you're running this locally, you're going to get this UI similar to if you're running the Spark UI locally. This UI is also available through Databricks, obviously. And so whether you have a standalone script or notebook, or you're using full-blown managed Spark on Databricks, you can still see these results through a nice clean UI. For instance, we're able to search on an R-squared metric here and say we only want to see runs above a certain threshold of R-squared, right? And we'll again look in the demo, but if you selected these, you could then compare them, and you get a similar interface to the graphical components within the the Databricks notebooks, where we could see, okay, as this hyperparameter change, how did these metrics change? Really, when did like performance meet our threshold for success or accuracy, right? And what that lets you do is compare models from not only multiple runs, but also even across multiple teams and multiple users. So you could have a data science manager that really isn't even necessarily writing code. Maybe they just want to come in and observe the results of these experiments, understand what their team is producing, whether they're making progress, whether they're on track to meet certain benchmarks for a deployment. And then we'll look later, they can even now say, okay, this model is the one I want to go to production, and you can track its lineage too. I want to call out, and we'll look at it in the demo, over here, we had to log all these parameters manually. One of the things that they announced last year and then extended this year was auto logging. And so you can enable by default any model trainer or training pipeline is going to automatically log all of its available parameters and metrics. So instead of you having to sort of maybe go through and loop over all the available parameters or metrics within a certain library, it's now native, and you're not going to run into a case where you like forgot to register R-squared and now you wasted a bunch of compute time and, you know, didn't get that included. So always cool stuff coming out of there. Now, ML projects, that's the format for packaging, right? So this is how you make reusable and reproducible data science code. And so really it's just a directory with code, and it could be a Git repository, it could be whatever, and it uses a descriptor to specify the dependencies within it and how to run the code. So you can see it's if you've used, for instance, Azure DevOps or something like Condas, it's just a simple YAML file. And so in this case, it's called ML project. And you can see it defines the entry points, some of the parameters we need, like where the data file is, what our regularization value was, like we set over here. And then you can tell it what to run. So in this case, we're going to run a Python training file, and then we're passing in these parameters that it's going to accept on how to run, and then we do some validation to make sure it ran, and run this file to ensure that everything is kosher and ready to move forward. Now, this got extended even further. It's sort of a separate project, but they're now officially supporting projects within the Databricks UI as well. I'm going to be talking about some of the more new and abstract features, I guess, for lack of a better word, that came out of the Spark AI Summit in next month's user group. And the data science workspace, and specifically projects, is one of the things I'm really going to highlight. I'm hoping to even have access to the private preview by then so I can show off a demo. But it's surprisingly similar to this. I say surprisingly tongue-in-cheek. It's really neat to see how these things have incubated and grown over the intervening years. And now they have basically full-blown support for this at the workspace level, rather than it just being a specific component of MLflow. So I'll be interested to get my hands on that and see what you can do with it. And so once you have that created, you can also specify dependencies, for instance, through a Conda environment or another similar package manager. You can also have multiple entry points. You can run projects through the command line tool if you have the MLflow command line tool installed, or if you install it on your CI/CD server. And so this is, you know, what it would look like to run one of those projects. And you can see it's pretty straightforward. You can even run it straight off of a Git repo. And so again, this is generic on purpose. So it's going to fit in with whatever CI/CD or MLOps solution you already have in place. And then what it's really doing for you is automatically setting up the right environment and running that, making sure that if you're using the tracking API, it remembers which project version got executed, what Git commit it's from, what parameters you were using. And then that makes it so that you can easily rerun the same code in the future for the, you know, for instance, for an audit, or if you're doing a tech talk like this. And the project format is huge for being able to share reproducible data science code. You would not believe how hard that is to do oftentimes. And so within your company or open source community, wherever it might be, it makes it so that there's sort of lingua franca for data science experiments, which is awesome. So when you combine MLflow tracking and MLflow projects, you get a really nice tool set for reproducing, extending, and experimenting with your data. So they go a little bit more into detail on some of these in the blog post we'll share, but that's sort of a high level for projects. And then finally for models, it's similar. It's just a convention for packaging up a model in multiple formats. They call them flavors. And so what MLflow lets you do is deploy whatever flavor you want. That could be staging, that could be prod, but it's sort of, think about it like a tag on a model. And so each ML model or each MLflow model is saved just as a directory with those arbitrary files, and then the descriptor file of what flavors it could be used in. So for instance, here we have the flavors scikit-learn, and then it specifies what that means, and then the Python function version, right? And in this case, both have a pickled model, but only the Python function needs a loader module. The scikit-learn version only needs a specification of which version of scikit-learn. So you can see sort of there's branches and logic and flexibility within this format that makes it very extensible while also being really light. And so this model makes it so that you can use tools that support, in this case, scikit-learn or Python function model flavors, right? And so that could allow you to deploy to a bunch of common model types on platforms that support those. So any model that supports, for instance, the Python function flavor could be deployed to a Docker-based REST server or to a cloud platform such as Azure ML. If you wanted to define a UDF and Apache Spark for batch and streaming inference, you could do that too and include it. And then if you output those MLFlow models as artifacts within the tracking API, MLFlow is also going to automatically remember the project you ran, like we talked about before, and which RAN they came from, and sort of have that lineage. Okay, so I want to look at a new feature from October of last year, the model registry. So that integrates with the MLFlow models feature that we were just talking about, and it builds on top of the existing capabilities to share out ML models and collaborate, while also integrating more natively with your typical like experiment staging prod flow. And so it's just enhanced model management on top of the nice model API for reproducibility. So, you know, if you think about like what we were just looking at as, you know, bricks or building a house, then, you know, this is like having, you know, an actual like foreman or a construction manager, right? And so the way this works, you can kind of see the GIF on the right. I'll talk through it. Once you have model serving enabled, a Databricks cluster will launch, which is hosting all of your registered models, and they each have REST endpoints. And each model is running in its own unique content environment that contains the environment that it was trained in, which again is stored as part of the parameters of your model file, right? Now, once that endpoint's running, you can test those queries, as you can see right here in the Databricks API, and see, you know, with this request, what's my response going to be, right? Here they're doing the classic iris data set, so you can sort of see back the classifications that they're getting. So once you see that, then you can integrate with the packages or endpoints that it natively supports to deploy that out, or, you know, elevate it up from, say, staging to production, right? Now, one thing I want to point out is you don't just have to use Databricks. You can also submit them using your own REST APIs, which again is huge for that user acceptance testing component of CI/CD, because if you're using something like Jenkins or Azure DevOps and you've already written a test suite, you don't want to sit here typing stuff into a UI all day, right? And so this is really nice, and it makes it easy to kind of keep track of where your project is at. And so oftentimes when you start with like an initial model or an experiment, and then over time you iterate, produce better and better versions of the models, model serving basically just follows you along throughout that process. So if you have version 1 of a model that's already in prod and you want to try out some new version, you can register it as staging or feature branch or whatever, and then test it, make sure that it's robust enough to be deployed, and then someone can come in and elevate it up to prod status and move it up the pipeline. Now, since this model has serving enabled, the new model versions are automatically launched onto the cluster as they're added. So once you register them, they're ready to be tested on the cluster or by, you know, whatever your testing framework is, like I was talking about before. They also, earlier last year, added in the new runs sidebar. So we talked about, let me go back here, this UI for MLFlow. So the run sidebar is a feature of Databricks that more natively integrates with that UI. So we still get, if you click this button, I don't know if you can see that very well, we'll look at it in the demo, you still get out to the full MLFlow UI. But you can kind of see here some quick parameters and metrics from our run, like what a parameter is and what our tracking metric is, built into your Databricks UI. And so in the same place that you see comments or revision history, now you can see native integration with MLFlow and the status of your model as you're experimenting. It's not the biggest deal in the world, but it's a really nice tool for a data scientist doing rapid iteration using sort of this notebook paradigm, right? And so it bridges the gap between iterating through a bunch of different notebooks, keeping track of which code you're using. We'll look into it, but basically each of those runs is also integrated with the revision history of the notebook and your data set. So you can see again, which version of the code was this, which data was it using, et cetera. And so if you're using managed MLFlow on Databricks, they even take a snapbook of that notebook revision. So you could basically time travel back to it, just like you could with Delta, and see which created the training run and have that as part of the run metadata. And so this is a really neat little tool. We'll look at it here in a second in the demo. And then finally, the most recent announcement, which is just really cool, kind of expected, but at the same time, you know, no one was sure when. So model serving. So we've talked about all these components allowing you to deliver your ML models on, say, Azure ML or on Docker or SageMaker or whatever it might be. Now Databricks can host it. And so it's a turnkey solution for hosting ML models as REST endpoints. Similar to everything we've been talking about up until this point, it's trying to be as agnostic as possible while just being a simple plugin for people that need it. And so it's automatically updated using the ML model registry we've talked about. And that makes it so that data science teams can own the end-to-end life cycle of real-time machine learning models all the way from training into production. Now, if you already have something in place for this, it's still going to work natively with that. But if you need a place to serve and you haven't been able to sort of cross that barrier we talked about earlier for production deployment, then this is a huge win. And so it's natively integrated with the model registry. And what the model registry can do is store your models from all your different machine learning libraries, have multiple versions of them, your prod, review, feature branch, whatever it might be. And then model serving serves them up using the stages. And so you could say label your latest production model as model/blah/production. And then that's where production is going to live. Well, you could go to /staging for staging, /UAT for testing, whatever it might be, and they'll just host it at those URIs. And so underneath the covers, the model serving is managing the compute clusters for you, handling the containerization, handling the environment creation to be able to execute those requests and ensure that they're up to date and healthy. So it takes really all the mess out of it. So that's another one I'm really hoping to get access to the private preview of so that I can see what it's all about and start creating some demos around. I see that being a huge component of future projects that I architect out. Now, just briefly before we jump into the demo, I want to talk about kind of the design philosophy behind MLFlow. So it's a API first open platform. So we've seen throughout, you're able to accept runs, models, whatever, from any library and language. A model could be as simple as a Lambda function that MLFlow deploys into Docker, Azure ML, whatever. So really that's enabled by building around REST APIs and the command line interface. It's going to work like any other, Bash command line interface based tool, right? PowerShell, whatever it might be. Similarly, the modular design. It lets people use whatever components they care to use from MLFlow. You don't have to use all three of the components we talked about. The key thing here is it really is a split branch. If you want to just use the model feature, you could. If you just want to use the model serving like we talked about, you could serve it up from some other set of libraries. And that makes it easy to integrate into existing ML platforms and workflows. And we've also seen with some of those new features we talked about, it's what makes it so extensible and able to integrate with other ML platforms and workflows so easily. And that's enabled by having distinct components between your tracing, your project features, and your models features. And again, you could use any one of those distinctly, and now we see that's even, we're having things built on top of those too. So that's the deck for this month. Before I jump into the demo, I kind of want to open up the floor for questions about what we've talked about so far. And I would request that not everyone speak at once. All right, I see Scott's hand is up.
So this is almost a reverse question, but it's so impressive to see what MLFlow has done. What are its weaknesses? Why wouldn't I want to use it, and what's missing?
So if you have trouble, for instance, getting bandwidth from your company to say develop out on some new platform, and actually I'm going to reshare the deck real quick because I want to emphasize something. Let's go back to this slide. So what if, of no fault of your own, you had gone to your management and convinced them that any one of these packages was actually the true way of the future? Like if you had said, no, it's Azure ML, or it's MLeap, or actually we're going to do SageMaker, right? And now all of a sudden you're coming back and you're like, no, really, this one's the holy grail, right? We've seen attrition from that. And then really the only other reason I could think of is we also have seen companies, I've spoken to them, Databricks has talked about it, where the IT staff, the side of the fence that's managing things like your web infrastructure and where you're deploying and who gets to decide what goes to production, is separate from the data science team. We're sort of seen as like the harebrained mad scientists who aren't that great at coding, and really like we shouldn't trust anything we write to go to production, right? So it's sort of within that camp. If you have other thoughts, I'd be interested to hear it, but that's sort of where my head goes.
No, it's actually interesting. I didn't really think of that angle, but in a sense, as data scientists, we own, like you said, the model creation piece, but oftentimes we pass it off to IT to go to production. And it's almost like we're breaking that mold a little bit, which will cause potentially some tension, which is that we could go to production or they could go to production. We'd all like to use the same tool, but if they already have an in-place process, it may not be including MLFlow.
Well, yeah, and it's like, hey, you just wrote the movie or TV show. You don't necessarily get to direct it, or you don't get to do marketing, right? And so I think, again, one of the really cool things about how like platform agnostic and open this is it allows you to even have a parallel workflow where even within our own little biome, we could still have a full end-to-end state or dev to production deployment stack. And then at whatever phase of that stack, that pipeline, that management or IT or whatever team feels comfortable with, they can sort of pluck out our assets in an open platform agnostic way and deploy it on whatever, the grown up company wide deployment engine is, right? But even
Interesting, yep.
within that, we still get everything we want. We still get the big playground. We still get to own the whole life cycle. And so really it's the best of both worlds for everyone. Okay, Eddie?
Yeah, I was just gonna using that scenario you were just talking about there,
Mhm.
where the data scientists are kind of doing their internal testing. I think both parties could use MLFlow independently, and so you could do it in your internal development, kind of like you're saying, and then for the official CI/CD pipeline could also be training models and evaluating them using MLFlow. So
That's a great point.
Even in that scenario you're talking about, I think it would apply. It's just it may be a little bit more complicated doing it independently, but
Well, and I was trying to put myself in the perspective of like, ooh, those IT guys, right? And
yeah,
like
absolutely.
assuming they're not willing to accept MLFlow at all. But no, you're perfectly right. And I want to emphasize again with this ML flow model registry, and then also the new serving component, really they don't have to be involved in any phase other than the end. They can pick up MLflow just for that serving or just for that registry component. And all they would need is artifacts from the team that handles the initial components. And so you could have one team running full stack end-to-end MLflow for everything. And you could have another team that's maybe just using it as one component as part of their broader CI/CD pipeline for the whole team or whole company, and it would work perfectly well. It would, yeah, be a great synergy even.
Absolutely.
Cool. Thanks for that point.
Yep.
Any other questions about the deck? Okay, cool. Let's move over into the demo. So let me. Okay, so you should be able to see my Databricks workspace here. Okay, and so I should already have a cluster running, but we'll dive into our notebook here. And by the way, I've created a GitHub repo for the mixer streams I've been doing, just so that people could like recreate those notebooks. I've also started hosting the demos there. So you'll see in our revision history, we're synced up with that GitHub. And so I'll share a link for that. But in the future, you'll be able to find all of our code samples and notebooks and everything else there. So that should be easier if you want to reproduce some of this. So this is coming straight off of a recent Databricks blog post about MLlib and automated MLflow. So what we're going to be looking at is how to use the automated MLflow tracking to track model tuning from an MLlib model. And so we're going to be using a decision tree model. If you don't know what that is, really just think like your flow chart or your decision tree. Like, if I'm picking where to go to get dinner, maybe it's like, is it a weeknight or a weekend? Am I in the mood for a pizza or am I in the mood for barbecue, et cetera, right? Now, obviously, being in Kansas City, pizza wouldn't even be a consideration. It would obviously be barbecue. But what the decision tree does is essentially creates that for you based off the data and tries to differentiate it. Now, when we track the learning process, there would be nothing to track if we were only trying one model with one set of parameters, right? So what we do is do hyperparameter tuning here for the tree learning algorithm. And that lets us sort of track what combination of hyperparameters give us the best accuracy across certain metrics. And so hyperparameters in the case of a decision tree could be the depth, the number of available leaves on a certain branch of the tree, what the threshold is for splitting between leaves, etc. Now, we're going to be training this on top of the classic MNIST handwritten digit recognition data set. It's sort of an image recognition or deep learning data set to just recognize handwriting. It's one of the models that the post office, I believe, originally used when they started automating their mail sorting process. So let's go ahead and load that in. And so this is going to create 2 data frames you'll see, and we're going to go ahead and cache them because we're going to be reusing them pretty heavily throughout. And so we can see there's 60,000 training images and 10,000 test images. Sounds good to me. And then we can sort of display, and we see that these are all already all the features are already vectorized here. So it's ready to be trained on. Each of the features just represent different pixel intensities on a scale of, I believe, it's 0 to 255. And so we're going to use those to try and determine, so like this is a 5, right? And it has this intensity vector. You know, this is a 0, 4, whatever. And so we're going to try and use these vectors to predict that for the training set. So next, we'll define our ML pipeline. So we want to use a string indexer to convert the labels into categories rather than continuous values. If we fed this in as is, it would treat them like numbers between 0 and 9 rather than sort of A, B, C, D. And so we tie that together in with the rest of our pipeline. Pipelines are objects available through the Apache Spark ML libraries that piece together different components of machine learning algorithms into workflows. I would recommend checking out some of the links within this notebook if you're less familiar with some of these ideas. And again, if you have any questions about it, feel free to speak up. So we're importing our decision tree, our string indexer, and our pipeline. Now we're going to create a string indexer. We're going to tell it what column contains our labels or what needs to be indexed, and then what the output column is going to be called. Then similarly, we tell the decision tree classifier what it's classifying on, and then we make a pipeline that chains together the indexer and the decision tree classifier into that pipeline. So then this is where the automated ML flow tracking comes in. So we want to tune this pipeline's hyperparameters. Well, while tuning, ML flow is going to automatically track any models produced by a cross-validator, along with some of their evaluation metrics. So what that allows you to do is examine the behavior of tuning those parameters and what effect that has on the accuracy of the model. So in this case, we're going to be looking at max depth, which is how deep the tree can be at various depths, and then max bins determines effectively how many different continuous features you have. So we are going to maybe bin pixel values. So if you chose 2 bins, you would have either 0 or 1, black or white, right? So then we define what our evaluation metric is. So this is how we're going to decide what a good model means. It's what we're sort of tuning our hyperparameters against. So if we choose weighted precision, then we can go from 0 to 1 accuracy. So we're going to go ahead and use that as our metric, and we import that from the evaluation library. And then finally, from tuning, we can import our cross-validator object and a parameter grid builder. Now, we've talked about the cross-validator. What a parameter grid builder lets you do is feed in parameters, feed in lists of parameters for different parameter objects like max depth and max bin. So you see here, we're associating within our tree object, the max depth can be 2, 3, 4, 5, up to 8. Whereas bins, we're only testing 2, 4, and 8. And so what this does is essentially does a cross product between the 2 lists. So we're going to test 2 and 2, 2 and 4, 2 and 8, 3 and 2, 3 and 4, and so on, and look at which combination of parameters results in the best metric value, right? And so we create a cross-validator that gets our pipeline as its estimator, our evaluator object as it's an evaluator, our grid as its parameter map, and then we tell it the number of folds we want to do. That's essentially the number of cross validations. Now, we could make this higher if we were doing it for real, but you know, we're not actually going to serve this up, so we'll keep it small. So then we run cross validator. The cross validator is able to check to see if an MLflow tracking server is available, and if it is, runs within the MLflow there. And so underneath our current run in the log info, we could see cross validator already exists. If it didn't, it would create a new run, right? And then within each submodel, or the number of folds within the cross validation, it's going to log a run for it along with the evaluation metric. And so we can see here, it ran 54 little Spark jobs. It did our training, tracked the test metrics, logged them out, and then I tracked the run ID for later when we're going to do the model registry. And then all that's evaluated. So this brings us over to the runs sidebar. So over here, I can see all the runs I've had, right? Now, if I click on View Experiment UI, and I do, if it loads, and if I do params.max bins equal to 8, then I can see all the runs I had where my max bins parameter is 8. I could have done this with max depth, whatever. I could have also filtered by values of certain metrics. So I can select all these, and I could download the results, like if we wanted to, you know, hand that over to a client or let someone else look at it. But in this case, I want to click compare. And so I get this nice graphical interface. And so I could, for instance, select here my average weighted, or sorry, my, let's say, max depth, right? And then average weighted precision here is fine. We can see as we go up in max depth, we go up in precision. So it seems like this precision of 8 is going to be pretty good for us. And so you can see just from this example how this is a really convenient way of evaluating an ML model while also having reproducible, shareable results. And so if we went back over to here, I just wanted to point out, if we click within one of these, you can see the parent run, you can see the metrics we were using, you could see any notes I added to the model, like for instance, hey, this is ready for prod, and you can also tag it if you want to. And so really it's a nice little interface for ML. Now, the next piece I wasn't able to get working on, so I'm running the Databricks runtime 7.0 for ML. This morning when I reran my notebook, it was crashing out on a certain library that got changed over, but this code is still relevant. I think it's just a different library I need to import. But what we would do to register this with the model registry API is give the model a name, and then create a registered model using the API. So you can just use MLFLOW.register model. And for instance, in this case, we can tell it where the model lives, give it the artifact path, and then generate a string for the model URI. So it's going to be the run ID that we got from above, right here. And then it's pairing that with the artifact path to sort of create that URI. And then we register the model, again, like up here, with the URI and the model name. And so we were able to successfully register it. And so if we went over here to the models tab, we could see this model. Now, again, there was an issue with the path, but you can see when it was registered, who created it, what stage it's in, and if it has any pending requests, right? You can also add a description for it, like this model recognizes text, and we'll look at that next. So once that's created, you can also set up a little function to see when it's ready. Like for instance, if you wanted to set a flag on the REST API on whether or not it should try serving this up yet, and it just polls whether or not the model is ready based off the get model version function. And so before it's ready, it's going to say pending registration and then go up to ready. If it's not able to find the path, it's just going to cycle through failed registration. So once it's ready, you can add a model description. For instance, this model recognizes text, and then you're good to go. It's registered. We can interface with that same model. Like for instance, if we did a new run that was even better, we could pass that run ID in, say that this is the staging version of this model, which again, if we register it with the same model name, it's automatically going to be pushed into staging like we saw in the slides, and then we'll be good to go. And someone could click into that model, view the run, see the notes on why we thought that it was performing better or ready for prod, and we'd be good to go. So that's a brief demo of what you can do with MLFlow. There's going to be some extended demos on this and some of the new functionality that I'm going to be doing through my live streams coming up. So, you know, watch out for that. But yeah, that's the demo for today. So I want to open up the floor again for questions about that, and also sort of our broader office hours segment. If you're running into any Databricks issues in your project, or if you're curious about how to approach a problem, whatever it might be, I want to just broadly open the floor. And if we don't have any questions this week, that's fine. You can always reach out to me on LinkedIn as well, or my email. But we're pretty close to the end anyway, so I'd be more than happy to just give everyone 15 minutes back on their Tuesday. Hey, Eddie.
Hey, Spencer, real quick. Is this the notebook that you demoed? Is that available for people to look at? And where did you get that from?
Yeah, absolutely. Well, so you'll see, so two places. So one, and let me see if I can actually get to it from here. Yeah, there we go. That's what I was hoping for. So I'll drop this in the chat. This is the go-to place for all of my live Databricks content. So you'll see in here, we have notebooks for all of the streaming episodes I've done, but also within the Valorum Databricks user group sessions folder under June, you'll be able to find this notebook. And then if you want to read more about what we were doing at the top, this is the blog post where we imported the notebook from. Oh, that's the wrong link. That should be to Databricks, not to GitHub. Let's see. Yeah, I'll fix that. So this is coming from a recent blog post. It was a Databricks workshop in advance of the conference, talking about some of these new automatic tracking features. So I'll replace that link, and I would encourage you to read from the Databricks side too. They always have great insight there. So great question, Eddie.
Were you sharing, by the way? I didn't know if you were trying to share something. I just wanted to make sure.
You.
No worries.
Yes, I will share now. Okay, and this time I'm going to do it right. So over here on this link, and I'm going to share it in the chat now. This is where I've been hosting, like I was saying, all the streaming content. You can see the episodes for my Mixer sessions, and then we have Valorum Databricks user group sessions now, and in the June folder, you'll find this notebook. And then I'm posting that in the chat, and then I'm also going to replace that link up at the top with the link to the actual Databricks post. I believe it was just this. But yeah, so that's how you can find these notebooks and all the notebooks I've been creating for our Databricks content here. So I'd encourage anyone to check that out.
Perfect. Thank you.
Yeah, absolutely. And they, believe it or not, over at Databricks have a bunch of great content like this. So, and Microsoft actually has been expanding their Azure content quite a bit too. So if you're ever curious about how to approach a new feature like this, that's a place I've definitely been starting for a lot of things. Okay, did I see another hand go up? I don't want to deprive anybody of the ability to ask questions, but again, I'm broadly available. I swear if you go on Mixer any given day, you're probably going to find me live. All right, it looks like that was a false flag. So I'm going to go ahead and call that a user group. Super excited for next month's session. We're going to be focusing exclusively on the Spark AI Summit and the Databricks Tech Summit. Just talking about new features, new best practices, things we've learned from those workshops. And I'm going to hope to have some other Valorum repliers on from some of the other teams within our data-driven enterprise group to talk about what they saw as well. So that should be exciting. As always, feel free to drop me a line too if there's a future session you'd like me to cover. I'm sort of planning on doing some data lakehouse content later in the summer and also diving more into the end-to-end ML ops and more advanced enterprise grade ML flow content like we talked about today. So thanks for attending, and I will see you next month.